those efforts. I'm out of time, and I recognize Mr. Weber for 5 minutes.
Thank you, sir. Dr. Green, I really appreciate your testimony on innovative research taking place at NREL, particularly in the areas that could be game changers for renewable energy technologies like advanced computing, the chairman mentioned, and materials development. But when you look at the budget and compare EERA and NREL, our lead renewable energy lab received $315 million at FY 2019, or about only 13% of EERE's budget. In contrast, DOE's Nuclear Energy Lab, Idaho National Lab, received $924 million, or 69% of the Office of Nuclear Energy's total. If your lab received a larger percentage of EERE's total budget, which, as we've noted, is by far the largest of the applied energy programs at DOE, what other types of innovative research could you undertake? Are there currently any areas of fundamental or early stage? You've been chatting with the chairman about that. Elaborate some more on that for us. What are some things you could do? I'll give you more time on that, but you can't due to funding restraints right now.
I would say currently the examples that I gave in terms of for solar, the more forward-looking research and looking at the more advanced technologies to understand how to improve the efficiencies and the performance, that's one area. The science of reliability, when you have these modules out there for years to understand, to predict how they're going to perform, that's going to be important.
Are you able to model the wind blade difference variation?
No, we absolutely can do that. We're able to model and visualize, and these kinds of calculations provide guidance for experimentalists to work on. With regard to wind, those new challenges are daunting because, as I pointed out, you're looking at towers and the entire span going 250 meters. We need to understand the atmosphere and interactions with the atmosphere at that level. We don't at all. That's a major, highly collaborative program that we have to solve. Trying to optimize the wind farm performance is actually a grand challenge, as it turns out, and it's a grand computing challenge. And you're going to have to begin to validate what you predict as part of it.
Are you able to model that? Of course, Texas, on the west side of Texas, the western plains, that we'd call, has a lot of wind farms out there.
Yes, absolutely.
Talk about off the coast as well. Are you able to model the difference between onshore turbines and offshore turbines?
So we're very good idea. Currently, most of the work's being done on onshore turbines, and we understand quite well. And it's a huge collaborative effort between us, Sandia, Oak Ridge, and all the national labs and academia. The offshore wind turbines, there's works beginning in that area. They present very different challenges. They're out there that tend on average to be larger. They tend to be floating and tethered by a range of things, and they experience much more extreme forms of weather and things like that. So there's a bit more work to be done. Okay. There's a lot more work to be done. Well,
let me do a follow-up to Mr. Stein over here. Mr. Stein, in your opinion, wouldn't it be better investment of tax dollars? I know I appreciate you taking a look at the draft legislation, but wouldn't it be better, in your opinion, investment of tax dollars to focus on the kind of fundamental research we see at the national labs instead of individual grants to companies?
Sure. I think that's the fundamental argument I was trying to make. And some of the things that were mentioned in Dr. Green's testimony sound like things like how to manufacture a wind blade that can be moved in pieces that can be moved on a road. That's a manufacturing challenge that's really the responsibility of the industry, rather than the government to come up with the technical corrections to be able to manufacture and install some of those things. So I think it's certainly some of the things that Dr. Green is talking about make perfect sense to be part of NREL's portfolio, but I think some of the.
But be careful about where it goes, because in the end, you mentioned it could wind up actually limiting what private companies are willing and ready to do.
If these companies end up trying to meet benchmarks for materials or wind turbine height or whatever that are set by the federal government, they focus on those benchmarks rather than thinking, is there a different way to do this? Is there a different location for this? Those sorts of things. That sort of innovation.
Right. Well, I appreciate that. And Ms. Hopper, I want to come over to you. As a former air conditioning contractor, I paid very close attention to the cost of energy and what air conditioners drew or the more efficient units didn't draw. You mentioned in your testimony that part of the problem was in the permitting and all of the things that went with getting lined up. You said, I think you said it could save as much as $1 per watt in soft costs. That's fairly high when you figure a light bulb is 100 watts, okay? So I think you might want to go back and look at that. It's maybe not as high as $1 a watt. A single light bulb, an incandescent light bulb, can be more, 40 watts, 75 watts, maybe $1 a kilowatt.
I will certainly go back and look at that, but
Yeah.
I'm fairly confident that that's the right number. But we'll go back and look at it.